Why not do radio astronomy? Previously I discussed why it's a good idea to do radio astronomy and work in the radio. But it can't all be good. What are the limitations to working in this regime? Firstly, the need for areas free of radio interference. You'll struggle to use an optical telescope in areas with large amounts of artificial light, and the number of stars you can see on a clear night in the countryside is far greater than that in the city. The same logic applies to radio. To do good radio astronomy, you need to work in areas with limited use of radio frequencies. In some cases we use protective bands, so this bit of radio, for example, can't be used for communication, therefore making it easier for radio astronomers to use. But there's still problems, and there's still radio interference. You've got radios and mobile, but you've also got other radio frequency radiation. If you go to a place that has a radio telescope near it, you'll often find that things like microwaves are put in Faraday cages so that their radiation doesn't emit it. You see, the thing is, I mentioned a major advantage of radio astronomy in that radio wavelength travels well through the atmosphere. Of course, this is an absolute pain if you're doing radio astronomy, because the fact that it travels through the atmosphere is really useful for everybody else. Radio communication on Earth is brilliant, and that's going to cause you trouble. This limits the amount of places you can build a radio telescope. You really can't do much if you're very near a city. You have to go out to the countryside. And if you want to do really high quality top-end radio observations, you need to secure off a large area around the telescope and make it radio quiet, a massive inconvenience for anyone who lives there. That's difficult. There's not a lot of nice ways to do that. For a second point though, we'll talk resolution. In short, let's say I see two objects in space that to me appear very close together. Can I tell if they're two separate objects? Well, this is where we talk about resolving. If I can resolve a small angle than that between them on the sky, then I can tell them apart. If the minimum angle I can differentiate between is larger than the difference between the two objects, then I can't tell them apart. They appear as one blur. If you think of looking at a city at night from a long way away, nearby you might be able to notice individual street lamps. A long way away, everything blurs into one. We know a formula, a simple formula for resolution. I'll not go into detail about how this is derived, but I'll just pick out an important point here. Minimum resolvable angle depends on telescope size, or the size of the aperture you are looking with, and wavelength. This is idealised. Reality has the existence of the atmosphere, for example, and reality has imperfect telescopes. But the fact is, the longer the wavelength you use, the larger the minimum angle you can resolve for a given size of dish. So, with radio astronomy, you need to build big, either one massive dish or combining lots of smaller dishes. One massive dish is obviously going to cover the problems of just being huge. Everything that gets involved in moving it about and pointing it to areas on the sky becomes more difficult and more expensive. If you want to use multiple dishes, you need to link them up so that things that arrive at the dish at the same time end up in your results at the same time. Otherwise, everything goes wrong. So you need a very complex system to bring those dishes together. This is not easy, this is again expensive. So in summary, that's a good start of the difficulties of radio astronomy. You've got large and complex machines with very few places to build them. On the other hand, you could try to overcome these difficulties. While desert locations are limited, the demand for radio telescopes is also fairly small, so you can generally work through this. Also with interferometry, you can build on lots of separate small plots of usable land, rather than taking up an entire field every time. So there you have it, a few of the weak points of radio astronomy. I think I'll leave that there.